Hope you're having a nice Monday. Day 14 of our increasingly misnamed series, moving to Gas County. Um, we're here. We're doing stuff. All right. Well, it actually, as you can see, um, we left off on Saturday the 16th, and we have about 600 lines to go through. So we left off right about here. Let's start implementing our phase one of changing our agents inside of our city from basically one-offs that you have to know to use into departments that have charters that reject work, that try to create expertise and build on that. And so there was like a Claude outage when I left off, and so we did a lot of puzzling last time, but this time it might take most of the hour we've got here just to go through everything that it did. And I'm not going to try and go through everything, but we'll skim and we'll try and get some highlights here. So it started to make a formula for accepting work. Each department is going to try and look at a piece of work before it starts working on it and say, is this for me? And if so, then it will start working on it perhaps. We learned that these formulas can be composed. There's a way to, say, use a formula as part of a formula. And so everyone's working formula is going to have this little snippet about accepting work. And we're trying to write it in such a way that if we have department's charter in a standard location, then we should be able to, the agent should be able to figure out, does this task that's coming to me conform to the work that I'm supposed to be good at or not? And one other thing that we're doing is kind of judging the capabilities that each department has and trying to keep the agent within the four corners of its capabilities. So we had a really interesting talk last week about can we make departments start to evolve their own internal jargon so that they reflect expertise in some sense. And then we might be able to use other metrics and other methods to see has the agent decided to start confabulating in a generic way rather than sticking to its specialization that we're trying to have it grow and create. Right? So I felt like that was all interesting. Still early stages for all that. We haven't actually written those tools that will say this agent sounds funny because it's not talking like someone from this department, right? That's sort of like our ultimate goal, is to be able to detect confabulation when it's going outside of the four corners of its charter or its expertise. But yeah, hopefully we'll get there. Hopefully this is phase one of many phases as we like get through this. And ultimately, it's possible that we'll be able to turn this system into a sort of pack. Um, Packs are sort of like drop-in agents for cities or drop-in procedures. And what we're making is kind of a sort of a meta routing kind of pack, if you want. Um, it's not exactly the same, I don't think. Like as far as I know, packs are mostly confined to like agents, prompts, formulas, that kind of thing. And we're introducing some new artifacts that are sort of required for each department. Like what do I know? What should I work on? What's the mission of my department? That kind of stuff. And it would be hard for you to work without those things. I think that that's a similar thing to human company as well, right? Like every now and then the team should sit down and say, hey, what are we here for? What kinds of work should we accept and reject? And if we're being asked to stretch, should we redefine ourselves in some way? All right, so we can go through and look at all of these as well. So it's been working. It's been adding stuff into our gas city here. And I have been thinking a tiny bit about, we created this name tutor, and it'll be interesting to see if that sort of spreads out to the different theming that we might see as we create agents and their names and things like that. Are we getting sort of like a classy British city that if we had just renamed it something else, the computer would be taking different poetic inspiration from that? I actually don't know the answer to that. But let's look at the formulas. And it did say that it was creating this formula to accept work. So let's read it a little bit. who's the requester? And so this is a thing that in a normal ticketing system, you would definitely have this. Um, Either people or systems that are requesting work, and you have somebody to talk to if you have any question about the work, and perhaps there's a kind of two-step going on where, as a resolver, I do some steps that I need the requester to go verify something or to push the process forward, something like that. And they're sort of the interlocutor on the other side. The resolver is the person on the answer side, and the requester is kind of the person on the question or the need side, if you want, or demand and supply. There's lots of ways to think about that. Um, but yeah, it could definitely be a conversation. And ultimately, as I mentioned in previous session, the requester and the resolver kind of need to agree one way or another that the question has been satisfactorily answered or the request has been taken care of. Sometimes it makes more sense for the resolver to do that, to say, hey, I've taken this as far as we can possibly go, so I'm going to close it. Sometimes you wait for the requester to say, oh, I accept that this resolves the problem that I brought. And so there's that. Or we could have like the consensus between the requester and resolver, where they both sort of ask each other, do you feel like we're done? Do you feel like we're done? Okay, okay. And then we can close the ticket finally. So we're adding some metadata um, onto the bead, the request, that says, what are we getting out of this um, decision, this formula, right? And so at the end, we're going to say, is this in the right department? Are we taking it, accepting it? And maybe there's a reason that explains how this does or doesn't conform to the charter. If it's out and if we know where it's supposed to go, then we could, as a kind of courtesy to the requester, try to reroute them appropriately. Uh, and then if there's an actual notes entry on this, this is interesting. I didn't know that the caching was getting written into this. And this is kind of an interesting, like, I guess what you say is structure, you know. Um, it implies a certain kind of structure for notes or way of thinking about how sure we are that we're picking the right verdict for conformance. If I have a recipe to solve somebody's problem, clearly, like, if they bring me that problem and I can find my recipe, I should definitely do it regardless, right? Um, Either that or like maybe that's something I used to do and it's gotten stale and it's no longer part of my charter and maybe I should like reap that somehow. But in general, right, like if you know how to help somebody, you just do it, right? Okay. And then specialists will, do this kind of stuff to find their metadata. Okay. So the steps, we have a conformance check step. Um, and this is really for the agent to do. Decide whether the requested work is in lane for the department. Cool. And here is the expected location of the charter for an agent. Yeah, this is interesting. Again, it's sort of like if you it has to do with class. This is a classification question, right? The agent has to classify a request as being on topic or off topic for its department. And like every classifier, it could make mistakes. Um, if it includes a lot of them, like it includes a lot of requests that it shouldn't, that's sort of like a false positive, if you want, right? And so it's tuned the classifier to be too accepting, to say too many things are our work. And if it's more strict, if it's too strict, it'll turn it down and say nothing is actually our work, when there might be requests coming in that should be our work. Those would be like false negatives. And so we could actually, if we had some ground truth for our classifier that say, well, you should have taken this one, and you shouldn't have taken this one. They're labeled separately. like without this process. And then we see whether or not those tickets are actually classified the way that we expect, like things that should be in are in fact labeled as in, things that should be out are labeled as out. Then we're actually sort of we can provide that as feedback to the classification. Say, hey, you should have taken this, you shouldn't have taken that, and then it should ideally figure out why it did that and compose more rules or update the charter so that it either loosens or tightens the classifier, or it adds terms to the charter, those kinds of things. And those would be ways that it could sort of, the next time a similar request came in, it could do the right thing instead of the wrong thing. And this has something to do with how classifiers work in more, say, statistical or mathematically precise contexts, if you want. Like, it's definitely possible to treat a classification problem as a statistical mathematical thing and say, hey, I want to solve this classification problem in general. I'd like to write a function that would determine whether work should be labeled as ours or not ours. And I'll do that with a lot of examples. And you can use all of the input data that you like. You can get whatever signal you want out of the input data, maybe all the text in it, or certain things in its metadata, or the requester, or something like that. And you could start to mathematically calculate when a request looks like this, it should be labeled like so. And you're kind of building this function that says, oh, well, when I see a new input, then all of my past experience leads me to believe it should be labeled in a certain way, right? And so, yeah, there are like well-known statistical methods for writing that kind of function approximator or classifier, if you want. And so this is an interesting way because it's not exactly using those same mathematical constructs. Like there is no, deep learning neural network that you are feeding back verdicts to. But you could. It could be added. Could be a thing that either an individual department decides to do or a thing that we start building as a classifier. The problem with them being that, of course, you need lots and lots of examples to sort of converge on a good boundary between in and out. The other thing that's kind of weird about this is that the classification that we're doing about this charter is kind of a moving target, right? So, for instance, if a team split its responsibilities and sent some functions to another team, um, then the classifier would be out of date, right? If you ran it again on some old inputs, then you might get new responses, and that would probably be important things to do, right? Is to if you actually did have like a mathematical classifier for requests, you'd want to retrain it after you change the charter, that kind of thing. All right. If it's out of charter, then mail a handoff. Close any sibling step beads in the molecule. That's weird. Perhaps. So yeah, this is sort of a way to we'll want to question this, okay? Um, let's start taking a couple of notes because just because the work isn't getting done here doesn't necessarily mean that it's not supposed to get done anywhere. Feedback on phase one. This is just like a scratch tab. When we close Emacs, it's going to be gone. We're not writing this down anywhere, but re mol accept work. Should the molecule be closed when the it is out of conformance, i.e., wrong resolver? Other ticketing systems would assign it back to the requester or another attempt at. triage. Maybe it's just the molecule of accepting this work that would get closed rather than maybe there is a distinction between the accepting work molecule and the actual user client and the actual request. So it might be I'm not quite understanding that maybe this molecule just means like it needs a way to abort, and the way that it's going to abort is like not to do the successor beads underneath this molecule. Maybe it's just aborting the accept work. All right. Continue. Okay. So again, we've got this like conformance check is actually its own little workflow, right? It's got 4 steps inside of it. Let's note that. We've talked about this in previous sessions. I think it's just a thing that it's going to do regardless. Okay, so the next one, we're looking for prior answers. So you can see that like it's going to check for conformance before it goes on and looks to see if it has instructions inside of its document. It's sort of a double-edged sword. Like, what if there was documentation about how to answer the requester, but for some reason the classification step failed? That would be sort of counterintuitive, right? Because what the department can do is kind of governed by what it knows how to do. Should cache lookup inform whether the department does the work? It knows how to do it. If it's cached. Even though it's not its job, or it's somebody else's job. This was like a really ugly phrase a lot of places I worked. They were like, hey, don't just pass around work because it's not your job, right? If you know how to do it, just, be a pal and help out. Which I think is like a good aspiration to have. We should want to help each other out. I'm just going to throw this in junk. Phase 1 routing. All right. Hopefully that's usually my junk file just gets cleaned out every now and then. Okay. Look for the notes. There's the notes file. Generally, it would be in here with this path. And then do some grepping. There's a lot of ways to what a human would do is they would have a general idea of what's in the notes file. They might grep for things, but usually I would do that if I'm like looking for a particular command for a thing that I know how to do. I wouldn't usually go, can I find a matching keyword in my notes file that has something to do with the request that's in the request file. Because, again, as we've gone over before, the requester is not necessarily asking the question in the same language that the department is using, like in its notes file. And so this idea that like the requester is going to get the great keyword into the question, and then the resolver, without understanding it, is going to just try and use that in the answer. Yeah, this is definitely like a questionable way to go. And so we might be asking about sort of this common concept inside of Gas City and other things. Is this a Zero Framework Cognition violation? Meaning, should we just send this decision out to a model again? And right, we are sort of asking the model, but then we're telling the model, turn off your brain and do this stupid thing. And it's not that that's wrong per se, right? We do want our tools to push down cognition into deterministic tools. But we don't want to send a sort of crude tool to do cognition's job. Yep. Okay, so that's our accepting work. So we might have to do something new, or, you know, if there's no relevant entry, then obviously we've got more work to do to sort of figure out the customer request, because it is in our bailiwick, right? But we don't actually know what to do. So that's sort of like, this conforms to my model of human ticketing systems. This is what I would do if I were on call. Okay, let's continue scrolling through what it gave us. We're going to use this inside of the Gas City oracles molecule. We're asking like how to do something in Gas City. So let's take a look at that one. And it's interesting to me that I might have said this before, but I'll mention it again briefly, right? Like a lot of these workflows molecules are really specific to one agent or another. And some of them even say, hey, if you're not the this guy, then don't do this. Which is a sort of natural thing, but it suggests that we should have a way to package together a department and its associated agents and workflows, its charter, its knowledge base, that kind of stuff. And right now it's all very flat, right? It's like if there's a workflow in the city, then it's inside of this directory, and it could be for, we could sort of crudely namespace them by prefixing them with, oh, well, this is for this agent or that kind of thing. All right. So we could look at how to. It's now going to have an accept work step right here. So here in extends, we're going to have this accept work workflow that we just went through. And then it's going to write back an answer to the question. That's kind of the idea. Answer a question about GC internals. All right. Research and cite. This is interesting that it has more classification. Interesting. Okay, so apparently we were doing some of these things in the past, right? Like we were trying to say, build your repertoire in the knowledge base by learning something new. And so some of that has moved up into the acceptance workflow. So if it's just checking right away, do you have more work to do? Is this going to be like a research project for you? And it would be on a miss, but not on a hit. Let's move some of this code around. Interesting. So it's telling this a little bit about how the workflow works. Because it has a parent, we're doing a couple of different steps before you go on and do the sort of main event of looking for new stuff, write an answer, and so on. This seems like a pretty generic thing. Yeah, it runs for every department that adopts small except work. It sort of implies as well that we should have our agents kind of extend or otherwise compose this thing. Maybe there's a way to do that as a skill um, that all of them could use. Let's put that in. GC Oracle prompt template. There seem to be common steps for acceptance workflow related to um, hashing knowledge and what to do on a hash hit or miss. Should they be encapsulated in a common way? For instance, we could provide some text for all these templates to insert. Some shared, or we could try to encapsulate hash operations as a skill. We could also do that relative to a certain knowledge-based design. Right now we are using markdown files, but that could change. A different knowledge base may have a different skill. All right, let's continue. Yep. So now we're just going through. Yeah. Make some citations. Notice any version drift. Write the note. Get it into the bead. If an entry is stale, then you can replace it. Nice. This implies a certain level of mail. Mail is the way that we're gonna let the requester know that their thing is ready. All right. So we're kind of cobbling together some features of issue tracking systems like Jira or Linear. You know, it's okay. It's just how things are going to be for a while until we standardize more of this stuff. Okay, let's keep looking here. All right, so we finished phase one. Now we're going to try the test. Ooh, that's interesting. I actually don't know the answer to that question. It's nice that it's been doing memories and trying to remember things from the conversation with me. Um, it's not clear to me how that is affecting the context or sort of future conversations that I've been having with it. I guess what I assume is that when we're remembering things like that, it's lazily loading them as needed. It's not like peppering my context with them every single time. And yeah, hopefully that's how it works. But and providing some persistence and understanding my preferences and things like that could be important. Mm. This is a sort of this is the nomenclature for beads being open, in progress, done, that kind of thing, or parents, sub beads, that kind of thing. Okay, the formula composition works as designed. That's cool. Um, the new molecule did have a merged step list in the correct order. That's great. Looking for some mail. Yep. Steps 1 to 4 are closed. Great. It was a complete success. Excellent. So we actually did a thing. We actually made something that um, we installed it in our first agent. And then, it also tested something that it shouldn't be able to answer. Hmm. It's about Linux desktop tooling, but it said we don't do that. How pleasing. How nice that something that we tried to do actually worked. And like, yeah, obviously from 600 lines ago, this was hands off. This was all the mayor editing these charters, editing these agents, and then testing them to see if our formulas were working as designed. The agent refused rather than tried to be helpful. Um, Look out, world. Did we do it? Did we solve AI? One small follow up. Hmm. There was also the session instance name instead of the template name. Yes. Next move. Phase 2 is blocked by the work query narrowing. Yeah, the next priority is this making sure the agents only get work that's aimed at them. And that pools of agents can discover work that is labeled for their pool if you want. Um, let's pass along our feedback file. Hmm, I guess. Okay, tilde junk. I'm just fixing this. That was weird. The left arrow didn't work. This equals sign. That's gonna be hard to remember. Okay. Okay, so we did that. I saw the out of charter test was successful. Was successful. It looks like phase 1 is complete. That's great. I have some feedback in tilde junk. Feedback on phase 1 routing. Okay. I did that equal sign again. Um, Absolutely, yeah. To continue on, um, Zero 2. All right, there we go. Great. Cool. I mean, this is the dream, right? The dream is the computer works without you for a while. You come back and you say, "How's it going? What's next? Do you need anything?" So yeah, pleased to see that that happened over the weekend, even though we were dealing with that cloud outage for a bit. Okay, um, let's give it a couple of minutes. Last time we were working on, we did a palisade, a long palisade. But I do really love 5 cells or 15 cells as I was playing it. It's a lot of fun. What's Philomeno? Oh yeah, yeah. Okay, so this is called Phil in Simon Tatham's. Let's turn to that. And I definitely think of this as if you've ever played Go, game of Go, very similar to the squeeze to Suji in nature. We can kind of see that this is the same idea. The idea is that we have certain blocks in this puzzle, and a block has a border around it, and the number of things inside that border all contain the same number. So this block that is 2 big, every cell is going to be filled with 2. This block that's 1 big, every cell is going to be filled with 9. We have a bunch of things out here where it's not clear if I look at any blank square on here, what number is going to be in here. And so the goal of this puzzle is to write all of the numbers. The other rule that we have is that we cannot have 2 of the same number next to each other, right? Like this would cause a region of size 3, but the number, they're all numbered 2, right? Contiguous regions that have the same number are like together. So you can see that how that causes a violation. And we're going to use that quite a bit. If you play the game of Go, this one feels really familiar to me, like the squeeze to Suji, you could say. I just get the same kind of feeling where there's not enough room for everything, and as you start to sort of squeeze numbers out of their various starting points or tubes or whatever, then that squeezes other numbers. And because this has a unique solution, we have to feel that eventually every single thing is going to get squeezed into something. Sometimes we'll run across a situation where, like this area right here, um, there's no way for us to put a 1 or a 2 here. It's too big to fit a 4 in here. The region itself, right? I won't get to 4 cells here. I can't put a 5 because if I grew 5 out from here, then I have a region of 1, a region of 2, and then it would jump right here to a region of 7 5s, and that's illegal. So anything 5 or above, kind of running into the same problem. There's just not enough room. So it has to be a 3 right here. And even though there was no original number, the shape of the puzzle dictated that I'd have to make a region that had all 3s in here. So I think that pretty much explains the rules. So you start usually with these really easy ones where there's only one place for this region to grow, and so you put that number out. Here's another one. Notice how this 3, we can't finish it off because we don't know if we need this cell or this cell. We can see that it finished off kind of, it turned this into a sort of one-way only kind of region. Here's another interesting one. We fan out this 5 as much as we can to say these squares. So if we made all of these 5, if we avoided this cell right here for as long as possible, we'd only get 4 5s in there. So now we're forced. We have to put the 5th 5 right there. There's nowhere else. So this is definitely like, it had to be a 5. If it wasn't a 5, there wouldn't be enough room for all the 5s right here. And so sometimes we'll make counting arguments like, well, we know that behind the veil of this 2 and this 5, right, we need to have at least 3 cells for these 3s and 4 cells for these 4s. And then there's like 4 cells of wiggle room behind all of that. And yeah, sometimes it's more obvious. Oh yeah, those actually saturate all of the space that's behind here, and that means that we can know that they kind of would use up all of this, and that these other formations would have to sort of leave behind this region. Here's a 4. We kind of do the same thing we do with the 5. We go, okay, well we're avoiding this square as long as possible. We do a 4 and a 4, and there's nowhere else to go. We have to put the fourth 4 right here. I hope you can see how that could be helpful. Like, let's see, what's another one? Same argument for this 5. We grow it out this way as far as we can, then we just got to put a 5 right here. And a similar kind of thing happens with this 8 right here. We just cut it off so that it has a lot less room to maneuver. And we could extend it all the way down here, but then we have to start growing the 8 outward. And note, just to be long enough, notice what that did to the 5. There's actually only 5 cells left right here for this 5 to use. They're all 5. And only one place to go with this 3. Yeah, so by the time we're done with this puzzle, we'll have like filled in a number in every single one of those cells. Okay, it does seem to be telling us stuff. Maybe we can catch up with the conversation a little bit. All right, let's engage with this feedback. The question bead should stay open. Closing the question bead steals that choice. Yes, abort the accept work workflow. Leave the question bead open. We'll do that. That's fine. Okay, good. Conformance check is multi-step. Internally, it does these things. The substeps are sequential and brief. Okay, fair. I'm willing to experiment with that. Should cache lookup affect routing? Cache hit is evidence we answered this. The charter should be the source of truth, and flag cache hits on out of charter questions. Anything we ever answered is in charter by virtue of being cached. Sort of implies that you should clean out your notes periodically when you don't do that anymore. Or you should move it out to archive or something like that. Okay. grep is prototype. Semantic matching is better. Oh, what does ZFC stand for? I thought that's in all of the prompts. My impression was that this was a universal thing here, but oh, okay, maybe not. Okay. So, yeah. Well, we'll explain that to them. So, zero framework cognition. That's the idea that the framework shouldn't be doing cognitive stuff. Don't send a framework to do cognition's job, and vice versa. In the prompt template, fatten the formula descriptions. Persona and invariance. Tools cache or skill that parameterizes on backend. Yeah, worth working on once we have more examples. I agree. All right. It's doing the work query question. Okay. The principle inside of the Gascity code base that might be worth putting in our in common use in our agents. The brief description is I think it's here, contributing. Try linked off of contributing. Oop. I feel like there's a way to follow links. I'm going to try Control C, Control O. There we go. All right. This primitive test, I think, might be. I'll have it look at that. I can ask GC Oracle about it. My brief description is that tasks that require cognition should be done using cognition, while tasks that do orchestration should be done by the all tasks should be done by the framework. Cool. All right, we'll let it think about that for a minute. Keep doing some filling. We're kind of looking for ones that seem to require a lot of space or that seem to be kind of railroady. We're going to build out from those. So that 9, there was only one place for it to go. The 7 is out. This is 6 cells, so it's got to go out to this 7th one. And I think too that we're forced into this one. Yeah, I don't see any way around that. We're gonna have to connect up some way, but maybe we connect up this bottom way, or maybe we go this top way. And so these 3 cells are kind of undecidable right now. And we don't know if we're gonna have to go any further in 7, because we could squeeze everything in right here. But in fact, that's kind of a thing that we're gonna start seeing now. We're trying to place this 9 now. We need 9 cells. We could go in one cell this way, use up that space, but then we have to let this 7 kind of eke out around this corner. That accounts for 4 of these 9s. We could put one here, and then we're forced to come to this one. That's number 6, 7, 8, 9. We could notice that we just cut off a 3 here. We could notice that cut off a 7, and that cut off an 8. That forced us to put this 4 out here. We're not sure if it goes up this way or down this way. In general, like a decision like this, it's not a free decision by the time the puzzle is solved, because if there were 5 cells and only 4 of them accounted for, we could make it look either like this or like this. And since in this puzzle as in many other puzzles, we have that rule that there's a unique solution. In general, we could detect, oh well, this is probably not going to be filled. This has probably got to be filled in by the end of the puzzle, and so it won't be free to be 4. And so we could just sort of use that as an inference to say, oh well, this is how the 4 has to go. It's going to get cut off, and the only way to make a unique solution is to put a 4 in this corner. We don't have to decide that right now. We can sort of wait to watch that evolve. We have 7 cells for this group of 7. Now we're just filling in some consequences of that. Here's a 4. If we started it over here, 4, 4, 4, that's only 3. We definitely have to have one here. And then that would imply that we have to squeeze out this 5. Here's the 5th one. And that cuts off this 6 a little bit. Here's the 6th cell. See that 3, 1, 2, and then we have to use this one. That cut off this group of 5s. Oops. Hit the wrong number. 5s. That only one place for this 4 to go. And now we have this sort of unlabeled thing. Remember that can't match any of the numbers around it. It's got to be a 1. Can't match any of the numbers around it because it would expand them beyond their appropriate size. How's this 9 group doing? 1, 2, 3, 4, 5, 6, 7, 8. This could be a 9. 9. This one would have to be a 9. Yeah. So another kind of relaxing puzzle. I don't find this one super difficult, but let's see here. 1, 2, 3, 4, 5, 6, 7. So we'd fill in the rest of it as much as we could, then we'd be forced to put an 8 right here. We've got this group of 7s now that got kind of cut off from this other area. 3. Here's the 4th 7, 5th, 6th. And this thing happened where 2 different 7s from the original puzzle kind of joined up. And sometimes we'll have to decide whether we think they're going to join up or not. There's only one missing cell in this 6. We've got 7 cells, and we're going to put 6 of them are going to be 6s. But that caused a surprising amount of ambiguity about which cell we're skipping. We can actually skip any one of these 4 cells, and we'll still be able to make a contiguous group of 6. So we just have to leave that for a bit. We do only have 8 openings now for this 8, though. So these all have to be 8. And as I said before, we got to put a 4 in this corner because it did get cut off. There's only 6 spaces for this 6. Only 1 space left for this 5. Only 1 space left for this 7. We've got 8 in this group of 9. We're not sure if it's going to be this one or this one. There is something I'm inferring about this cell. It has to do with whether we could put a 9 anywhere else around this group. If we did that, then this cell would be cut off from all of the others. And the only way to do a cell that's cut off like this is putting a 1. So that would make this 1 adjacent to it the wrong size. So we can actually conclude that no matter which cell we tried to put a 9 in, we didn't put it in this one, then we'd create this little corner that would mess up this 1. By the same token, none of our outside groups can actually reach to this cell. The 6 would get this close, and the 9 could get to about here. So this can't be the 6 or the 9. Obviously, it can't be the 9 either because it's adjacent to this 9. It can't be a 1, and it can't be part of a 2. So we're left to conclude that these 3 cells have got to get filled in with 3s. Only 1 place left for this 9, this 6, this 3, and then everything else is kind of cut off from each other. There you go. That's filling, aka Philomeno. Philomeno is an okay name. Hashiwo Kakedo, I think we oop, there we go. This is bridges and Simon Tatham. So we've kind of gone over this one. We were looking at it while we were looking through our catalog. Let's see what it says. Okay, that changes a few things in how I'm designing the formula steps. Agent cognition is spent on bookkeeping. Cache lookup causes framework ops. Deciding is cognition. The verdict writing is mechanical. Yeah, assigning the verdict to one or the other of the labels. I think that's what it's talking about. What does ZFC conformant look like? Expose primitives for bookkeeping, and the agent's prose only does judgment. Cool. New GC subcommands or pack local script equivalents. Let's think of it as designed at. Great. Okay, cool. It is remembering this. It did create that bead to go and look up the primitive test. Add a new bead. Great. All right. It says it's thrashing. I don't think that system memory usage is a little bit different in Linux than in Windows, as I recall. And it doesn't feel like it has something to do with whether we're tight on memory because it's all actively being used. I think ideally, you sort of want your computer to be, using its resources as best as possible. The only problem is when you go to get resources and they're all being occupied. And so it depends on, we could look into this a little bit. But this is definitely a problem. A session spawn thrash loop. All right, let's see. Yeah, so we can like concur on the ZFC fixes as technical debt. Feel free to file that. File that. I'm curious about the stuck agent sessions. Maybe we should. Maybe it has something to do with how we are invoking those sessions when we want them to do work. Might be worth another GC Oracle question on the right way to start sessions in Sling. Okay, I think I've got to leave pretty soon, but maybe we'll pause there and hopefully we'll get some good answers. But pretty pleased that we're trundling along and actually getting some work done toward our vision. of a gas city that has departments and slings work appropriately and refuses to work when it's not supposed to. So yeah, so promising stuff. So catch y'all soon.